All right, today we'll talk about 7.5, solving special types of linear systems. So what we have here are some vocab words that we've already discussed, but let's review them. A system of linear equations is consistent if there is one or more solutions, right? We said it's inconsistent if there are no solutions. The system is independent if the two lines are, when these are not dependent on each other, that is not the same line, right? A system is dependent if the two lines are actually the same line. Okay. When we solve a system of equation, there are three possible results, and we drew these on the board. We said if there's one solution if the lines intersect at one point. There are no solutions if the lines are parallel. And there are an infinite number of solutions if the lines are exactly the same lines. So let's look at one set of equations here and see what we might find. I'm going to solve this by elimination. I'm going to go after my x's. So I need the same coefficient but different sign. So I am going to multiply this first equation by -1. So I'll get negative 3x minus 2y equals 10. 3x plus 2y equals 2. So let's add these together and see what happens. Well, negative 3x plus 3x is 0. Negative 2 plus 2 is 0. 10 plus 2 is 12. 0 equals 12. Is that ever true? No. 0 does not equal 12. If you get something like this as your result, and the x and y's drop out, this means there are no solutions. And if we graph these two lines, we would find that they're parallel. So let's actually do that. We'll actually change them into y equals mx plus b, and we'll compare. Alright, so I'm going to subtract over negative 3x plus 10, and I'll divide by 2. That's that line. And I'll do the same thing here. Negative 3x plus 2, and I'll divide by 2. Notice they have the same slope, but different y-intercepts. So those things look something like, roughly, here's up slope of 3, down 3 over 2, and it's negative. So these lines look something just roughly like this. Therefore, there is no solution, and that's what this kind of thing shows you. Let's try another one. Notice I can actually add these equations together easily because I have a plus y and a negative y. So let's add them up. So 1x plus 1/2 x is 3/2 x. And then the y's drop out equals negative 6. So x will equal negative 6 times 2 over 3. Just negative 12 over 3 is 4. I think we might find that we have a solution. Let's see. If I plug in x equals 4, I get 4 plus 0 equals negative 4. Whoops. Sorry, I'm solving for y. Subtract 4. Y equals negative 8. So here you actually have a solution, don't we? Let's see what we have here. Now, I don't even have to graph to identify the numbers of solutions that I'll have. If my lines have different slopes, looking at them in y equals mx plus b form, there will be one solution. because they'll intersect at one point. There'll be no solution if we have the same slope but different y-intercepts. That's what we had right here. Same slope, different y-intercepts, right? And there'll be infinitely many solutions if they have the same slope and the same y-intercept, which means they are basically the same line. So let's look at this. Without solving the linear system, tell whether it has one solution, no solutions, or infinitely many. So I want to take these and manipulate them into y equals mx plus b and see what I have. So I'm going to subtract x over. I'm going to divide by -3. So my first equation becomes y equals 1/3 x plus 5. Right there. Let's try this one. We'll say -3y equals -2x minus 18. Divide by -3. Y equals 2/3 x plus 6. Well, guess what? Different slopes means one solution. Okay? Let's try over here. It'll be taking the first equation and I'm manipulating it. Now I'm dividing. So y equals -4/3x plus 9. And over here, let's see, I'm going to subtract the 4x over -3y equals -4x minus 27. Divide by -3 now. So y equals 4/3 x plus 9. Well, slopes are different here, right? So one solution. Let's do a story problem. One admission to a roller rink, a roller skating rink, costs X dollars. So admission, right, costs X dollars. And renting the skates is Y dollars, right? So a group pays $243 for admission for 36 people and 21 skate rentals. So the cost of admission is X dollars. So 36 times X will be the admission for 36 people plus 21 times Y equals 243. Okay. Let's look at this one. Now another group pays $81 and they have admission for 12 people and 7 skate rentals. So let's see if we have enough information to actually determine the cost of admission. All right, well, I am going to multiply. I'm going to get, this is 21. I want this to be -21. So I'm going to multiply this by -3. So here's the first equation, right? The second equation will be -36x minus 21y, and 81 times 3 is 243, so -243. Let's see what we get. 0, 0 equals 0. Well, this is a true statement, right? Our variables have dropped out, but if this is a true statement, 0 equals 0, we know we have infinite number of solutions, and these are actually the same line. But notice, we learned nothing about x and y, so we did not have enough information to figure out the cost of admission or the cost of the skate rentals. Okay, we found out though that these were the same lines. Did not have enough information. All right, I'm going to stop here, but let's review for a second. If you do elimination for a set of linear equations and you get x equals some number, we'll call it a, and you get y equals b, well, there's one solution, the coordinate point AB. If you solved a set of linear equations and your variables dropped out, let's do this one solution, and you got something that was 0 equals 8 or some false statement, then there's no solution, which means the lines are parallel. If you solve the system of linear equations and got a true statement, if that's true, it means there's infinite number of solutions and we have exactly the same lines, right? The two lines lie right, exactly the same line. The two lines lie right over the top of each other. All right, well, work on the homework and we'll discuss this if you have any questions. Thank you.